Aldenham Works, North London, March 1961, 4:47 a.m. The workshop floor stretches 3 football fields long. Sodium lights cast orange shadows across aluminum skeletons hanging from overhead rails. Bus RM324 arrived yesterday afternoon, bright red, fully operational, carrying passengers just 16 hours ago. Now it's suspended in mid-air, its body separated from its chassis, engine sitting on a separate pallet, transmission disassembled into catalogued components. This isn't salvage. This is surgery. Every 5 years, every Routemaster returns to Aldenham, not for repairs, for resurrection. The engineers here don't fix what's broken. They replace everything that could break. By Friday, RM324 will roll out identical to the day it first touched London's streets. The mileage counter will reset, the warranty will restart. The bus will be, in every technical sense, new. This is the story of a machine designed to die and be reborn. A vehicle so thoroughly engineered for disassembly that it outlasted every bus that tried to replace it. The Routemaster served London for 49 years, not because it was indestructible, but because someone understood that nothing lasts forever unless you build it to be rebuilt. London, 1947. The crisis no one mentioned. London Transport inherited a fleet of dying machines. Wartime buses, patched, overworked, corroding from the inside. The average double-decker lasted 12 years before rust claimed the chassis. Mechanics spent more time cutting out rot than performing maintenance. Replacement costs were eating operational budgets alive. The solution seemed obvious. Build buses stronger. Thicker steel, heavier frames, more durability. But A.A.M. Durant, London Transport's chief mechanical engineer, saw the trap. Stronger buses meant heavier buses. Heavier buses meant more fuel, more brake wear, more road damage. You couldn't outrun entropy with brute force. Durant proposed something radical. Don't fight decay. Manage it systematically. Design a bus that could be completely disassembled, inspected, and rebuilt on a 5-year cycle. Make maintenance the design philosophy, not an afterthought. The engineering team assembled in 1947 faced a paradox. Build a bus light enough to be economical, strong enough to carry 70 passengers, and simple enough to rebuild 2,000 times without losing dimensional accuracy. Every decision would cascade. Every component would need to serve the disassembly mandate. They started with the frame. Or rather, they started by eliminating it. The stressed skin revolution. Traditional buses used separate chassis, heavy steel frames carrying the body as dead weight. The Routemaster would have no chassis. The aluminum alloy body panels themselves would carry structural loads. Each panel bolted directly to neighbors, creating a rigid shell through stressed skin engineering. The weight savings were immediate, 3/4 of a ton. But the real genius was accessibility. Every body panel was a separate component with standardized bolt patterns. Corrosion in one section? Replace that panel. No need to cut, weld, or compromise adjacent structures. Aluminum alloy type RR58, chosen for its strength-to-weight ratio and corrosion resistance, would never rust. Steel chassis corroded from road salt and moisture. Aluminum oxidized superficially and stopped. A 40-year-old Routemaster body looked identical to new. The material itself was maintenance-reducing, but aluminum presented problems. It conducts electricity poorly. Welding requires specialized equipment. The solution? Mechanical fasteners throughout. Bolts, rivets, and screws. Every joint serviceable with hand tools. No specialized welding bays. No heat-affected zones weakening adjacent metal. Any mechanic with a socket set could rebuild a Routemaster. The first prototype, RM1, rolled out in 1954. It weighed 7.4 tons, lighter than most single-deck buses. The stressed aluminum skin had replaced 2 tons of steel structure with 1.25 tons of aluminum. It could carry 64 seated passengers and 8 standing. It accelerated faster than anything in London's fleet. Then came the real test. Could it be rebuilt? Aldenham Works, 1956. The assembly line in reverse. The 5-year overhaul system operated like precision clockwork. A Routemaster entered Aldenham, was photographed, tagged, and completely disassembled over 3 days. Body lifted from chassis. Engine removed. Gearbox separated. Electrical system unplugged at standardized connectors. Every component went to specialist workshops. Body panels, inspected for stress cracks, repaired or replaced, repainted. Chassis rails, checked for alignment, straightened if necessary. Engine, completely rebuilt. New pistons, bearings, seals, tested on dynamometer before reinstallation. Gearbox, disassembled, worn gears replaced, reassembled. Electrical, every wire inspected, corroded connectors replaced, entire harness tested. Reassembly followed the reverse sequence. Chassis aligned on jigs, engine lowered into position. Body panels bolted in sequence, each checked for fit tolerance. Suspension rebuilt with new bushings. Brakes relined. Fuel system flushed and tested. The final product left Aldenham essentially new. Not refurbished, rebuilt. The difference mattered. Refurbishment accepts some wear. Rebuilding eliminates it. Between 1956 and 1986, Aldenham processed over 2,800 Routemasters through 6 complete cycles each. The facility became the operational heart of London's transport system, more critical than any individual bus. The modularity doctrine. Standardization made the system possible. All 2,876 Routemasters shared core dimensions and component interfaces. Engines could be swapped between buses without custom fitting. The same body panels fit RM1 through RM2876. Electrical connectors were identical across the fleet. This created strategic flexibility. When AEC stopped producing engines in 1979, London Transport switched to Leyland units. Later, Cummins, Iveco, and Scania diesels entered service. The buses didn't care. The mounting points and driveshaft interfaces remained constant. A 1956 bus could receive a 1995 engine with minimal adaptation. Power steering became standard in the 1960s. Automatic gearboxes replaced manual transmissions. Electronic ignition replaced points and condensers. The Routemaster absorbed every upgrade without structural redesign. The platform was neutral. The components evolved. This violated conventional automotive economics. Car manufacturers profit from planned obsolescence, make parts incompatible across model years, force complete vehicle replacement. London Transport engineered the opposite: infinite upgradability within a constant platform. The financial logic was brutal in its clarity. A new bus cost £15,000 in 1970s pounds. A complete Aldenham overhaul cost £3,500. Run a bus for 5 years, spend £3,500, get another 5 years. The capital cost distributed across 10 years instead of 5. Double the operational life, halve the replacement rate. By 1980, some Routemasters had undergone 4 complete rebuilds. They'd been disassembled and reconstructed 20 times. Their bodies showed no fatigue. The aluminum panels remained dimensionally accurate. The buses performed identically to new. The unplanned longevity. The Routemaster was designed for a 25-year service life. It served 49. In 1979, London Transport ordered its replacement, the Leyland Titan. Modern, accessible, simplified maintenance. The Titans lasted 12 years before corrosion forced retirement. Their steel bodies couldn't survive London's winters. The Routemasters, built decades earlier, kept running. The 1980s brought the Metro bus. The 1990s brought low-floor accessibility requirements. Each new generation promised to retire the Routemaster. Each new generation failed first. The aluminum bodies outlasted every steel successor. Aldenham Works closed in 1986, a political decision, not an engineering one. London Transport privatized, maintenance contracted out. The 5-year overhaul system ended. Industry predicted rapid Routemaster decline. Instead, private operators continued service. They couldn't replicate Aldenham's systematic rebuilding, but the fundamental design remained sound. Buses received component-level maintenance, engines swapped, gearboxes replaced, body panels repaired locally. The platform's modularity allowed degraded centralized maintenance to fragment into distributed servicing without catastrophic failure. Heritage routes continued until 2021, 65 years after the first Routemaster entered service. The final operational bus, RM2217, built in 1965, ran its last scheduled route carrying passengers who weren't born when it first rolled off the production line. The lesson London forgot. The Routemaster succeeded because its designers accepted impermanence. Nothing lasts forever. Everything wears. The question isn't how to prevent degradation, it's how to manage it systematically. Modern buses use integrated monocoque construction. The body and chassis form a single welded unit. Repairing one section requires cutting the entire structure. Component replacement becomes structural surgery. When corrosion appears, the bus dies. The Routemaster used bolts. Simple, reversible, service-friendly. The entire vehicle could be disassembled with basic tools and reassembled without loss of structural integrity. This wasn't primitive, it was sophisticated restraint. The engineers chose simplicity over integration because simplicity enabled maintenance. The aluminum body wasn't expensive, exotic metallurgy. It was strategic material selection. Aluminum costs more than steel initially, but eliminates corrosion entirely. The life cycle cost calculation reversed conventional purchasing logic. Pay more upfront, eliminate replacement costs later. The 5-year overhaul cycle wasn't maintenance, it was managed regeneration. Accept that components wear. Schedule their replacement before failure. Never let degradation accumulate into catastrophic collapse. The system prevented problems rather than reacting to them. Durant's original insight remains valid. Longevity comes from designed impermanence. Build machines that can be taken apart. Use materials that don't degrade. Standardize components across platforms. Create maintenance systems as robust as the machines themselves. The Routemaster lasted 50 years because it was designed to be rebuilt every 5. The buses that tried to replace it, engineered for durability without maintainability, failed in 12. The lesson transcends buses. Systems survive through managed renewal, not static permanence. The Routemaster proved it. London forgot it. The buses remain, outlasting the wisdom that created them.